Yes, good morning to all of you. Myself, Mahesh Jagdish Pingle, lecturer, Electronics Engineering, Government Polytechnic, Ambad. So, dear students, in our previous lecture, we discussed about the virtual height and the critical frequency. Now, if we know the virtual height of the layer, then it is possible to find the angle of incidence so that the signal will return back to the ground position with some selected point. So, if we know this particular virtual height from the earth surface, so we can calculate this particular angle of incidence to send a signal for a particular point. So suppose if we know the virtual height, suppose this is particular point A, right? Now for sending the signal from point A to the point B, suppose this is particular point B, we want to send the signal. So let us have a look over here. Suppose this is your point A and suppose this is your point B. So we want to send signal from point A to the point B. So if we know the virtual height, then we can easily calculate the angle of incidence. So by which angle we have to use or the reflect the signal so as it will reach to point B. Suppose if the angle of incidence is 30 degree, then it will reach to point B. But if the angle of incidence is 40 degree, then suppose it will reach to point C. So if we change the angle of incidence, whatever the destination point, it will get changed. So we can say that if we know the virtual height of the layer, then it is possible to find the angle of incidence required to return the wave to the ground at a selected point. Now second case we have discussed, that is called as the critical frequency, and while talking about the critical frequency we said that if the angle of incidence is 90 degree, so suppose this particular angle of incidence it is 90 degree, then the value of maximum frequency reached to the ground, it is nothing but your critical frequency. So while defining the critical frequency, we define critical frequency as the critical frequency of the layer is defined as maximum frequency that is returned back to the earth from this particular point, return back to the earth by that layer when the wave is incident at 90 degree to the normal at this particular point. So if the incident angle it is 90 degree, what is the value of maximum frequency that is capable to reach earth surface, that frequency it is called as critical frequency. So we also discussed that the critical frequency for F2 layer is between 5 to 12 megahertz. So maximum up to 12 megahertz frequency itself gets returned back to the earth surface when angle of incidence it is 90 degree, right? Now in this particular lecture we are going to discuss the maximum usable frequency. So maximum usable frequency, it means what? Suppose angle of if the angle of incidence is 30 degree, then signal is reaching to point B. If we increase the angle with 40 degree, then it will reach to the point C. If the angle of incidence we make it is as a 90 degree, then suppose any point D it will reach. So at that particular point D, if we measure the return frequency, that frequency it is called as the critical frequency. So the maximum frequency reach to the ground surface when angle of incidence is 90 degree. Now if we want to discuss the maximum usable frequency, the concept is that if we further increase the angle of incidence above 90 degree. So previously we have taken the case for the critical frequency 90 degree. So when incident angle is 90 degree, frequency reached it is called as the critical frequency. So if we increase the angle of incidence, automatically it is possible to operate the signal at very higher frequencies rather than that of your critical frequency. So if the angle of incidence is above 90 degree, then whatever the frequency we will reach here, it is more than that of your critical frequency, and that frequency it is called as the maximum usable frequency. So while talking about the maximum usable frequency, we can say that the maximum usable frequency MUF is defined for a certain value of angle of incidence theta, rather than defining it to the theta equal to 90 degree or the normal as in case of critical frequency. This definition tells us that if the angle of theta is increased, then it is possible to operate the higher frequency than that of the critical frequency. So MOF is given by some equation. So here you are observing some equation. So maximum usable frequency, it is equal to critical frequency divided by cos theta. So which is equal to, if critical frequency is fc, then 1 upon cos theta. 1 upon cos theta is in the thing but the sec theta. So MUF is equal to fc sec theta, where theta is nothing but the incident angle, right? So if we increase theta, then it is possible to operate for the higher range of frequency. This particular equation, it is also known as the second law. Now here we can once again defining the MUF term as rather than defined as a highest frequency. So we say that MUF is not defined in terms of angle in practice, rather than it is defined as the MUF is the highest frequency that can be used for the skywave communication between any two given points. So if we want to send signal, suppose from this particular point A to the point B, and suppose if we know the virtual height, then the maximum frequency reached to the earth's surface with some critical angle, with some angle more than the critical angle, that is called as the maximum usable frequency. So MUF is always defined in terms of the highest frequency that can be used for skywave communication between two given points on the earth surface. Normally the value of MUF are in the range of 8 to 35 megahertz, and the highest operating frequency between 2 points is selected to be slightly less than MUF. So this is all about the maximum usable frequency. So we have to just keep in mind one thing, is that maximum usable frequency is the highest frequency that can be used for the skywave communication between any two given points on the earth surface. So this is all about the maximum usable frequency. In our next lecture we are going to discuss the further details about the skywave communication. So thank you very much.